Hello everyone. I hope everybody's doing very well. Um, in this tutorial, we're going to learn about the NumPy Python library. Um, NumPy is a short form of numerical Python. It's a Python library that consists of multi-dimensional array objects and a collection of modules for processing those arrays. NumPy library helps us to do mathematical and logical operations on array, Fourier transforms and modules for shape manipulation, linear algebra, and random number generations. Okay, so the n-dimensional array object. The most important object in the NumPy library is the n-dimensional array called the ND array. It describes the collection of the items of the same data types, unlike normal Python lists, which can store various data types. An ND array stores only items of the same data type, so you have to take note of that. Okay, to create a NumPy array by calling the array function and pass a sequence like object into it. The array function takes unlist object and returns a NumPy array consisting of the passed data. Okay, so obviously if you want to use the NumPy library, you have to import it. And over here I'm importing it as NumPy as NP, right? And if you want to create a NumPy array, you do np.array, and then you put in a sequence, you know, um, of items, be it a list or a sequence of strings and so on and so forth, right? So I did this, and this was my output. Okay. You can also pass multiple sequence like object into the array. However, the objects should all have the same length. Okay, so initially I have my data here, and in my data I have two lists. Okay, and then I put it into the array function, and this is what I have. Okay, you can see that shape of the you can see the shape of the ND array using the dot shape. The dot shape helps you to see the number of rows and columns the ND array has. Okay, so when we call the shape method or property on the ND array variable, this is what we have: 2, 4. It means it has 2 rows and 4 columns. So as you can see, 2 rows and 4 columns: 1, 2, 3, 4. Okay. You can also see the size of the array, which is essentially the number of rows times the number of columns, right? So in this case, 4 times 2 or 2 times 4, which gives us 8, right? And then apart from creating NumPy array with the array function, you can also create NumPy arrays in other ways, right? We have the NP zeros, where it takes in a number, an integer, which indicates the number of zeros you want to see in your array. So in this case, we say we want to see 5 zeros. So we have 1, 2, 3, 4, 5 zeros, right? And then another way you can do it is to put in the number of rows and columns, right? But this time you put in two parentheses, okay, where you put in the number of rows and columns, and then you have this. So that means that you have an MP0, which is an ND array of 5 rows and 5 columns. You can also use the np.ones. This time it gives you ones, right? You can also use the np.empty. This one gives you just an ND array of which is empty, which is null, right? You have this without it. So this function helps you create a NumPy array of a given shape and type without initializing entries. Okay, we also have the np.I. This function returns a NumPy array with 1 of the diagonal and zeros elsewhere, with 1 on the diagonal and zeros elsewhere. So if you can see np.I, you have ones right on diagonal and then zeros elsewhere. Okay, so I indicated that I wanted my rows to be 5, right? So 1, 2, 3, 4, 5, and I wanted my m to be 4, which is essentially the columns. We also have the np.arrange, which is very similar to the range function in Python. Okay, So when you call that method and you put in an integer, let's say 5, it gives you an ND array from 0 to 4. Okay, remember in Python indexing starts from 0. So from 0 to 5, okay? And when you do 2 to 12, for example, np range 2 to 12, it means you want to start at 2 and end at 12, but then 12 minus 1, okay? So 2 right through to 11, okay? You can also do the same thing over here. When you start with a float, then it means that your NumPy array is going to contain some floats, okay? Another parameter or argument you can add to that function is a step. Right? So the step is simply um, how many times you jump. Okay, you can take it literally like that. So we are saying that we should start at 4 and at 60, but then when you start at 4, don't go to 5. Jump 5 steps. So 4, when you jump 5 steps, you have 9. When you jump 5 steps, you have 14, 19, 24, 29, in that order, up to 60, which is again 60 minus 1. So the following are some useful attributes that you should know. D-type, which helps you to know the data type of the NP array or the NumPy array that you have. We also have the as type, which helps us to change the data type of the NumPy array using the as type attribute. Okay, so we created a NumPy array over here with the data type as int. Okay, so when you're creating a NumPy array, so you can specify the data type. Right, so it gave us, it was int, and we want to change it to float. Okay, so we just say array is equal to array.asType np.float, and now the change data type is now float. Okay, and then one of the important how do you call it, one of the important function in NumPy is reshape. Okay, remember in earlier we mentioned about knowing the shape of your array, okay, which is rows and columns. You can also reshape it. Okay, so over here we created a new array we use the np.arrange method or function to create the NumPy array, and then we said we indicated 20 as a parameter, so it gives us from 0 to 19, right? And we want to shape it. Okay, so there are two ways of reshaping. You can do new array.shape, and then you put in the number of rows and columns you want to, or you can just do new array.reshape, and then you have that. Okay, so we shaped it, and then we indicated we wanted 4 rows and 5 columns. Okay, we have that. Also, make sure that your rows, number of rows times your columns gives you the total length of the list. Right, so in this case the total length of the list was 20. Okay, so when you're indicating the rows and columns, make sure you indicate two figures which its product gives you the size of the NumPy array. Okay, so it's very important. So initially we said, oh, let's reshape it to 4 5, and then we can also change it to 10 2. Right, remember 4 times 5 is 20, 10 times 2 is also 20. Right, we can, so instead of doing new array.shape is equal to this, we can just do new.array.reshape, and then we put in a number, and it also works. Just like normal list, you can also do arithmetic operations on NumPy arrays, right? So over here we're doing some addition, we're doing some subtraction, we're doing some multiplication, we're doing some division, we're doing integer division, modulo division, and then we're also raising we're also doing some power operations as well. Okay, so pretty much it's very simple. We have two arrays, and then we do the various operations on them. And then you can also add and remove elements. So we use the np.append and np.insert. Append helps you add items to the end of the list, and insert helps you add item at a particular index. Okay, so just like Python list. So we have that. So we created an array, 0 to 50, with a step of 5, and then we appended 12 to the end of it. So as you can see, so initially it was up to 45, and then when we appended 12, we had 12 over here. You can also insert, so we are trying to insert 100 at index 3, and that is what we have here. So just like we can add, we can also delete as well. Okay, so you just use the np.delete, then you indicate the array. Okay, you indicate the array that you want to delete, and then you indicate the index at which you want to delete. Okay, so remember this was our original array. So after deleting the first item, this is what we have. Remember we deleted 0, right, the number at index 0, and now we have this. Okay, you can also delete multiple elements. Okay, so instead of deleting one index, we put the number of index we want to delete into a list, right? 0, 1, 2, and then it deletes everything. 0, it deletes all the elements at 0, 1, 2. Okay. We can also do resizing as well. So resizing is also similar to reshaping. Okay. So we have this, and when we resize it, this is what we have. Okay. And when you resize it, you can also delete by axis, or which means you can delete by rows or columns. Okay. And so in NumPy, axis 0 represents rows and axis 1 represents columns. Okay, so we are saying that we want to delete the array, NumPy array. We want to on axis 0, which is on the row column, we want to delete the third row. Okay, 0, 1, 2, 3, which is the row at index 3. Okay, so when you do that, this is what you have, the result after deleting a row. This is what you have. So you imagine we had the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So when you look at the result over here, it means we deleted 6, 7, which is at 0, 1, 2, 3. Okay, you can also do the same thing for column as well. So yeah, and you can also copy arrays to help you, do some manipulation. When you copy an array, whatever operations you do on the copy, it does not affect the original, right? So this over here, we're trying to prove that. And then we have broadcasting. Okay, so whenever we have a compatible array, which means that they are compatible on either column. So if you have two arrays, okay, either the number of rows are the same, or the number of columns are the same. Okay, we can use broadcasting to do some type of function onto a larger array. Compatible arrays will have the same number of dimensions on either the rows or the columns, and one on the other side. Let's take an example. Right, so we have np.range, we reshape it into 4, 4, so we have this, right? And then we have another one. So remember over here, we have the same number of columns. Okay, 1, 2, 3, 4, 1, 2, 3, 4. And now let's do some arithmetic operation. So you're saying a times b. So essentially what you're trying to say is that this 0 is going to multiply all the rows, 10, 30, 50, 70, right? This one is also going to multiply the first column, 15, 35, 55, 75. And this 2 is going to multiply 20, 40, 60, 80. And this 3 is going to multiply 25, 45, 65, 85. That's the result you have here. We can do the same thing for rows, right? So we indicated, we created a new array with 4 rows over here, right? And we are saying that A times C. Okay, remember A also had 4 rows, right? So essentially what we're trying to do is that this one will multiply all this, and the 2 will multiply all this, the 3 will also multiply all this, and the 4 will also multiply all this. So that's how you do broadcasting. So conditional expression with NumPy arrays, right? So essentially what we created a NumPy array, and we are saying A is greater than 30, and then when it's true, When a is indeed greater than 30, it will give us true, otherwise it will give us false. Okay, you can also put it into a list to return list items. Okay, you can also do the where np.where function or method. So if you use that np.where m is greater than 50, so it's just like saying give us return a list, where m is greater than 50, right? And it returns the index of the items, not the items itself. It returns the index of those items. Okay, you can also do here, you have np.where m is, greater than 70. If it is true, write greater than, else write lesser than. That's all we have over here. You can also do some mathematical and statistical functions, right, on NP arrays. So you can find the max, you can find the mean, and you can do that. You can find the max on the entire array along the columns and along the rows, right? So we over here we're finding max, we're finding mean, we're finding the mean, we're also finding the product, okay, the standard deviation, the variance, and the sum. Okay. We also have what we call the universal function. So universal functions are those that make element-wise computation on data in NumPy arrays. Their functions takes in the scalar value and returns a scalar NumPy array. So we created a NumPy array with the arrange method, and then we're saying np.square. So it squares, the item. So 30 times 2, 30 raised to the power 2, 40 raised to the power 2, 50 raised to the power 2, and so on and so forth. We also have the exponential. So in this case, it's going to be 30 raised to the power 30, 40 raised to the power 40, and this is what you have. We also have the binary functions, okay? So with the binary functions, essentially what we're trying to do is, so we have created two NumPy arrays. We're just trying to say maximum, right? So between those two, between A and B, return the maximum, right? So return the maximum of the two NumPy arrays, okay? And then we also do the same for minimum. And power is also there. So essentially we're trying to say that take A and raise it to the power of B, okay? So in this case, 45 raised to the power 3, 33 raised to the power 1, 78 raised to the power 6, and so on and so forth, right? We also have indexing and slicing. On Python lists, we can index and we can also slice. In NumPy array 2, you can also do the same thing. So we created a NumPy array, and then we are saying we want 2, 2. So we want at column 2, we want at index 2, which is row number 2. We want the column at index 2, right? So remember we have 1, 2, 3, 0, 1, 2, and then index the column at index 2 is 0, 1, 2, which is 90. That's what you have over here. And you can also do 0. So in this case, what we're trying to say is that we want the first row and all the columns. Okay, so when you have a number, you have a comma, and then you have that semicolon, it means you want a row and the rest of the columns. Over here, we want all rows and one column, which is the first column. Okay, you can also transpose arrays, so in this case, we're saying that we want to reshape it. So the reshape is 3, 4. When you transpose, it becomes 4, 3. It means the rows becomes 4 and the columns becomes 3. You can also combine arrays. So in this case, we're saying B is equal to 8 times A, right? Which multiplies all elements in A by 8, right? In this case, it adds all elements in A by 10. And then you can do np.vstack. So essentially, what it does is it stacks arrays vertically. Okay, so we created our ABC NumPy arrays, and when we stack them vertically, this is what we have, right? So it just stacks them vertically, and this one also stacks them horizontally. So puts everything in one line. You can also sort arrays. You have all this. So remember the the sort method, sorts it in place. So which means that you don't need to, indicate an additional variable. But if you don't want that to happen, you can use the np.sort method, right? And then you're good to go. You can also sort using this, and you can reverse it. Another beautiful thing is you can also save your arrays and reload them later. Okay, so you use the np.save, you indicate the name and the array you want to save. If you want to save multiple arrays, you use the savez arrays.npz, which is the extension, and then you indicate the two arrays that you want to save. You need to indicate one as x and one as y, right? And you can also save this into a text file. So that one is save txt array.txt, and then your array and then the delimiter, which is separated by a comma, and then you load them. You use the np.load array. This was the first one we saved, which was a single array. np.array.npy, when you call the variable, you have this, which is very consistent with what we saved the other time, right? The first thing that we saved. We can also load multiple arrays. np.load and arrays.npz. Remember, we saved the multiple array as npz. Okay, it's very important. And then you can also so with a multiple array, you can load the x, right? So load multiple into bracket x. Remember, we said one has to be x and the other has to be y. You can also load the y as well. And then you can also load the txt file, which is np.loadtxt, myarray.txt, and then delimiter, comma, right? And then when you do that, you have this. So most of the tutorial were modeled after this website, so you can also go there and check out for more information. You can also use the NumPy documentation on the web to also learn more about NumPy. This is not all the functions and methods in NumPy. This is just an introduction to some of the core ones that you need to know, right? And then after this tutorial, we're going to have some task, just like assignment, which is supposed to help you to practice NumPy, right? To do some practice to help you know. You remember, the more the practice, the better, right? So that it's going to be a Python notebook that we are going to share with you, so that you can also do some practice on your own. Okay, so catch you next time on another tutorial. Thank you very much.